Hello, welcome back. Today we're going to talk about limit. Specifically, we're going to be looking at limits at a vertical asymptote. Now, you may recall what a vertical asymptote is. If we have a graph, XY coordinate plane, XY, and let's say we have a vertical asymptote somewhere here at x equals a. There's our vertical asymptote. So what happens at a vertical asymptote is as a function gets close to it, as we approach the function, we can either go up the asymptote towards infinity, or as we approach the asymptote, we can go to negative infinity. In other words, we like to say either the function at an asymptote either grows without bounds to positive infinity. So we say positive infinity, we like to say it grows without bounds, or to negative infinity, which case we mean that it decreases without bounds. So what we want to find today is what's happening at an asymptote. And we're going to start with what the definition of a vertical asymptote is. The definition of a vertical asymptote is as we approach some value, see, as x is approaching c, as our function is approaching c from either the right or the left, the function is approaching positive or negative infinity. Now, keep in mind, this must be a single-sided limit. We can only approach an asymptote from one side. And we can kind of see from the example that we drew earlier, from the left, we're approaching positive infinity. From the right, we are approaching negative infinity. So in this case right here, since we're not approaching, the actual limit would not exist. So as a result, typically we want to deal with asymptotes, we only deal with the single side of a limit. So let's take a look at how we can solve these type of limits. In our first example, as x is approaching 3 from the left, so remember, we're approaching from the left, x approaches 3 from the left of the graph of y 1 over x minus 3. We want to find out what happens. Now, x equals 3 is a vertical asymptote, a VA, and we call them VAs for short. It is a vertical asymptote. What we want to know is what's happening at that vertical asymptote as we approach from the left. So there are two schools of thought on how we can solve this. Option one, we can draw this. Back in pre-cal, you learned how to draw rational functions. There's x equals 3 and 1 over x minus 3. We should remember what that looks like. It looks kind of like so. So if I'm approaching from the left, as I approach 3 from the left, notice we're going to negative infinity right here. So this is approaching negative infinity. There's the answer. On the right, what are we approaching? Well, it looks like we're approaching positive infinity. But we only want the left side. So from the left, this is approaching negative infinity. Now that's option one. So let's try option two. Option two says, oh no, I forgot how to graph these rational functions. Don't panic. We can kind of cheat a little bit. So for option two, what we're going to do is we're going to pick a number close to 3, but from the left. I'm going to let x equal 2. And if we do that, we get 1 over 2 minus 3. Now, I'm going to stop here because we have to talk about something. There is a rule we're going to work with. The limit as x approaches 0 from the right or left of a rational function. So in other words, what happens if we were to approach division by 0? And that's going to help us solve this, because if I try substituting in 3, I will get 3 minus 3, which is 0 on bottom. So the answer is really 1 over 0. And our rule for that, that's our rule for today. This is going to be either plus or minus infinity. So kind of a shortcut, we say anytime we divide by 0, we're really getting something infinitely large in the positive or infinitely small in the negative. So, so I know because this should be 1 over 0, this 2 minus 3 right here should be 1 over 0. So I know this is going to give me either plus or minus infinity. So why do I pick the 2? Well, 2 is to the left of 3, and 2 minus 3, this 2 minus 3 is a negative. So I know that the top is going to be positive, but the bottom is going to be negative. So what's the positive divided by negative? A negative. And there it is. Now, so once again, we get that negative infinity. So I know that sounded like a lot, but I'm going to show you, for example, number 2, just how fast this can go. Again, x cannot be 4. So I know if I were to plug in 4, I would get 1 over 0, which remember, this is either plus or minus infinity. So I want to just know is it positive or negative. So what I'm going to do is I'm going to let x be a number close to 4, but on the right. So give me a number close to 4, but on the right. 5. If I let x be 5, the bottom becomes 5 minus 1 squared, which is just positive. So the bottom is going to be positive. The top is already a positive 1. So if you notice now we got a positive divided by a positive, which is a positive. Therefore, the limit will be positive infinity. And you can do this in your head. I just want you to do this in your head. No thinking aloud in these. Just do them in your head. Let's try the next one. Again, I know if I plug in 3, I get 1 over 0. So this is going to be either plus or minus infinity. So I'm going to let x be this time a number close to 3, but on the left, like 2. Plugging in, the top is negative 1. If I plug 2 into the bottom, I get 2 minus 3, which is a negative. And what do two negatives make? A positive. So therefore, this would give us positive infinity. All right, try number 4 real quick. All right, so let's take a look here. All right, so pause the video, of course. We're approaching negative 3. Again, if I plug in negative 3, I get 2 over 0. I can't have division by 0. Now, be careful. This is not what we did on Thursday because we don't get 0 over 0. That's our indeterminate form. 2 over 0, that tells me this is going to become either plus or minus infinity right there. I just need to know which one. Well, the 2 is already positive, so I'm going to pick a number close to negative 3, but on the right. So be careful. Here's negative 3. That's the right, so negative 2. And if I plug in a negative 2, that becomes negative 2 plus 3, which is, of course, a positive. So this becomes a positive infinity. And there's our answer. Of course, the other options, you can graph these, and that's fine. But honestly, doing it this way, you really can kind of just do them in your head. And that's what we want you to get to. All right, so ready? What about the following? Notice this is not a single-sided. There we go. This one is not single-sided. So as a result, we need to look at both sides. But I'm just going to tell you this. The limit at a vertical asymptote doesn't exist. This is just going to be D and E. So if I get 1 over 0 and not single-sided, the limit just doesn't exist. And you might be thinking, okay, well, what if I have something like so? Both sides look to be approaching positive infinity. But you might recall earlier, we said that not all infinities are equal to each other. So we can't guarantee that they're the exact same value. Now, if you want to put something like this as positive infinity, you can. You can say this is in this case, it would actually be negative infinity because of the minus right there. But we prefer D and E to that anyway. So because honestly, what is in negative infinity? Any infinity doesn't exist anyways. Now, the more common thing that typically occurs is we get a situation like this, where one goes positive, one goes negative. And in a situation like so, well, they're not approaching each other, so of course it's going to be a DNE. All right, let's try number 5 here real quick. For number 5, this is a single-sided. We're approaching from the right side. Now, this one's kind of an interesting one. I can split this up. The limit as x goes to -5 from the right. I'm going to split this up as 5 minus x minus the limit as x goes to -5 from the right. 1 over 5. Let's make that a plus x. Sorry, plus x. There we go. Oh, typo. So, actually, matter of fact, I know I did wrong on this one. We're going to fix this again. So we are going to make this um, just a 5. A plus 5 is what it should be. That should be a plus 5 right there. That's what it should be. Now, got to fix it there too. There we go. All right, so if we plug in 5 here, we're going to get 0. 5 minus 0 is 5 minus 5 is just 0. That's just our substitution technique. Minus, plugging in the 5 here is a little bit trickier. I get that 1 over 0. So remember, this is either plus or minus infinity right here. I just have to determine positive or negative. Well, be careful. The top one is already positive. The bottom, I'm going to pick a number close to 5, but from the right. I am going to let x equal 6 and plug it in. 5 minus 6 is a negative, so the bottom is negative. So what happens here is we get 0 minus, and this becomes a negative infinity. And of course, the two signs change, becomes positive infinity for us. So this is going to infinity right there for us. Very easy to do. All right. So a couple things to kind of keep in mind. We don't like to say undefined here. We prefer or DNE on a single sided. It's not enough because it doesn't give us the direction that we need. Instead, we really prefer on a single sided plus or minus infinity because it's going to give us more information. All right, join us for video 2 and we'll talk about some trig functions. See you then.